Solving simultaneous equations can seem a little bit daunting, so I'm going to show you a way to answer them, and we are going to remember the instructions match, das, top. So match literally means find something that matches. Either the x's have to be the same amount or the y's have to be the same amount. Das stands for different, add, same, subtract. And then top means we go back to the top one. So I'm going to explain what I mean by this in the next slide. I want you to write down the questions and do them with me. So this one is question 1. First instruction was match, meaning you are looking for the x's to match or for the y's to match. Now in this particular case, and you can see from most of these, there is already something that matches. And for question 1, the x's and the y's match. So it doesn't matter which one we choose. I'm going to go with having the x's match. So let's quickly just erase that. If I make the x's match, are they the same or are they different? And what I mean by that is the signs in front. This is a positive x and this is a positive x, so they are the same. So das, different add, same subtract. These are the same, so I subtract. And so I'm subtracting the whole way through. Whatever I put the box around is going to be 0, so I don't need to worry about it. Let's look at the y's. I've got y, take away negative y. And negatives always cause a problem. So what is y? Take away negative y. What happens to those two negatives? Two negatives make a positive, and so what I've actually got is 2y equals 10 take away 2 is 8. So if 2y is equal to 8, then y is equal to 4. So I've done match, I've done das, and the last step is top. And what I mean by top is you put that back into any of the top equations. So let me go with the very top equation. X plus y equals 10. But what did I just figure out? I have just figured out that y is 4. So y is 4. So if y is 4, what is x? And so x is equal to 10 take away 4, x is equal to 6. Match, das, top. Right, so we've done question 1. We figured out that x is 6 and y is 4. Okay? You are going to try question 2, but before you do that, I'm actually going to do question 3. Right, so this is question 3. First step, match. Is there something that matches? Do the x's match? So I've got a 2x and a 1x, meaning the x's don't match. Do the y's match? In this case, they do. They are both 1y. So I'm going to outline them. So I've done match. Now I'm going to do das. Das is different add, same subtract. Are these different or the same? These are the same. Same is subtract. So 2x take away 1x is x. 11 take away 8 is 3. So I now know that x is 3. So I've done match, I've done das. Last step is top. So I'm going to put this back into the top. Now remember I said it can go into any one of the two top equations. Well, I quite like the look of the second one because there's no extra numbers. So I'm going to say that x plus y equals 8. But what did I just figure out? I just figured out that x is 3. So this is 3. So I'm now saying 3 plus y equals 8. So if 3 plus y is equal to 8, then y is equal to 5. Now make sure you've copied all of this down, or at least practiced it. You are now going to try questions 2 and questions 4. Pause the video, and when you unpause it, the solutions to 2 and 4 will be on the screen. Right, hopefully you've now tried questions 2 and 4. The answers to 2 and 4 are on the screen. For question 2, I matched the x's. They were the same, so I subtract. Y, take away negative y gave me 2y. 7 take away 1 gave me 6, y is 3. I put that 3 back into the top, and I got x to be 4. For question 4, I decided to make the y's match, or I saw that they matched. They were the same, so I subtract. 3x, take away x is 2x. 14 take away 6 is 8, so x is 4. Put it back into the top, and I got y to be 2. If you did not get that, maybe try again or follow with what is on the screen. So now it gets a little bit more tricky. If we look at question 5, I want to see that either the x's match or the y's match. So in this case, can you see that the x's don't match? One is 2 and one is 1. And the y's don't match either. One is 3 and one is 1. So because they don't match, I have to force them to match. And it doesn't matter which one I choose. So I'm going to decide that I'm going to try and make everything 2x. So I'm going to multiply the bottom equation by 2. I'm leaving the top equation the way it is, but I'm going to multiply the bottom equation by 2. So this means that it's 2x plus 3y equals 16, and 2x plus 2y equals 14. So I've taken that bottom equation and I multiplied everything by 2. 2 times x, 2 times y, 2 times 7. Now, if I go back to match dust top, these match. They are different or the same. They are both positive, so they are the same. Same, subtract. Different, add. So if I subtract 3y, take away 2y is 1y. 16, take away 14 is 2. So now I know that y is 2. So the instructions are match, done that, dust, done that, top. Top means I put it back into a top equation. Doesn't matter which top equation. I think I'm going to put it into x plus y equals 7. That looks like the most simple. But what did we just figure out? We just figured out that y is 2. So y is 2. So if x plus 2 equals 7, what does that mean x is equal to? X equals 5. All right? Pause, make sure you've got that written down, and let's try question 6. So again, just like question 5, nothing matches yet. I've got a 3x and an x, a 2y and a y. So they don't match yet. But you can choose what you want to match. Are we going to make the x's or the y's? I tend to make whatever is easiest. So in this case, I'm actually going to make the y's match because I like multiplying by 2. So I'm going to take this bottom equation and I'm going to multiply by 2 because if I do that, the y's will match. So my top equation is still 3x plus 2y equals 18. But my bottom equation will now be 2x plus 2y equals 14. The y's match. Are they the different or are they the same? They are the same. Same means subtract. So these are the same. Same means subtract. 3x take away 2x is 1x. 18 take away 14 is 4. So x is 4. Match, done that. Dust, sorted that out. Top, put it back into a top equation. So I'm going to put it into x plus y equals 7. But what did I just figure out? That x is 4. So I'm going to replace x with 4. If 4 plus y equals 7, what is y? Y is equal to 3. Now why don't you try question 7 by yourself? Okay? Question 7 is actually not like the ones we've just done. For question 7, the y's already match, so you don't have to do anything. But why don't you try question 7 on your own first? So as I said, for question 7, you don't actually have to do anything. Remember the instructions. Match, dust, top. First, match. Is there anything that matches? Yes, the y's match. They're both 1y. Next is dust. Different add, same subtract. Are they different signs or the same sign? They are the same sign. Same is subtract. So I'm going to say 4x, take away 2x, which is 2x. And I'm going to say 17, take away 9, which is 8. So if 2x equals 8, then x equals 4. So match, das, last instruction was top. Put it into a top equation. It doesn't matter which one. I think I'll put it into 2x plus y equals 9. But what is x? Or what did I just figure it out? I just figured out that x is 4. So I'm replacing x with 4. Now let's think about this quickly, because this is a common mistake. Is this 24? I'm hoping you said no. It's not 24. It's 2 times 4. 2x means 2 times x. So this is 8 plus y equals 9, which tells me that y is 1. Mark that. Let's see if you got it right. Now, so far, every question we've done has been same subtract. So let's see what a different add looks like. This is question 8. My instructions are match, das, top. So let's see what matches. Do the x's match? No, the one is 5 and the one is 2. Do the y's match? Yes, they are both 1y. So I'm going to outline them. Now, das, different add, same subtract. Do you see that in this one, there's a negative y and a positive y. So they are different signs. Different means add. So I'm going to add both. So what's 5x add 2x? 7x. 13 add 8 is 21, which means that x is 3, because 7 times 3 is 21. Then we go with top. So I'm going to put it back into a top equation. I tend to choose the ones that don't have negatives in them. So I'm going to write 2x plus y equals 8. But what did I just figure it out? Just figured out that x is 3. So I'm going to replace x with 3. So what does that actually mean? It's not 23, it's 2 times 3. So 6 plus y equals 8, which means that y is 2. Now, you've learned quite a few things. I want you to attempt questions 9 and 10. Try those on your own. Think about all the things you've learned so far about match, das, and top. Pause the video, give yourself some time to do 9 and 10, and when you unpause, the solutions will be on the board. Okay, so I changed my mind. I'm actually going to go through these with you. So let's look at question 9. Firstly, does anything match? I've got x and 2x, so that's a no. I've got 5y and 2y, that's a no. How can I make them match? I can either multiply x by 2, then the x's will match. Or I have to go really extra and multiply this y by 2 to make 10, and this y by 5 to make 10, and that just seems a lot more complicated, and we're getting there. So let's not do that. So instead, I'm going to multiply the bottom equation by 2. So my top equation stays 2x plus 5y equals 19. My bottom equation now becomes 2x plus 4y equals 16. Now my x's match. Are they the same or are they different? They are the same. Same means subtract. 5y take away 4y is 1y. 19 take away 16 is 3. Match, das, last step is top. I'm going to put it back into a top equation. I think I'll put it into x plus 2y equals 8. What did I just figure out? That y is 3. So y becomes 3. So I've got x plus 2 times 3, which is 6, equals 8. If x plus 6 equals 8, then x equals 2. Let's look at question 10. Again, does anything match? My x's don't match. My y's don't match. So I've got to multiply something. You might have decided to multiply by 3 and make the x's match. Or you might have decided to multiply by 2 to make the y's match. I am going to multiply by 2. Doesn't matter what you did, you will get the same answer. So my top equation is going to stay 3x minus 2y equals 7. My bottom equation is going to become 2x add 2y equals 10. Right, so what matches the y's? Are they different or are they the same? They are different. Different means add. So I've got 5x equals 17. Now, if you did try this one, you might have noticed that at this point, something seems wrong, because up until now, there's been no decimals. I need you to remember that decimals happen. And so the answer to this would be x is 17 over 5. And that's just unfortunately the way it is. So I've done match. Next is das, then top. So we're going to put that back into the top. All right, now I'm going to put that back into the top. So when I said top, I said it can go into any of the top equations, meaning it can go into this one, or these ones. Doesn't matter. I'm going to put it back into this one because there's the least amount of information. So I'm going to say that x plus y equals 5. But I know that x is 17 over 5. So I'm going to replace this x with 17 over 5 plus y equals 5. Now, I know that we don't like fractions. Fractions are just evil. So what I'm going to show you how to do is how to deal with fractions in a much easier way than trying to add them. The denominator is 5. Do we see that denominator of 5? I'm going to multiply everything that does not have the denominator of 5 by 5. So I'm going to say 5 times that y and 5 times that 25. And what now happens is I get 17 plus 5y equals 25. How awesome is that? No fractions. Now let's rearrange. I want to get 5y on its own. So I'm going to subtract from by 17. So I've got 5y is equal to 25 take away 17, which is 8. Which means that y is 8 over 5. Now, simultaneous equations, linear simultaneous equations, are considered a grade 5. This one we've just done, question 10, is still considered a grade 5. It's just a very high grade 5. Some of you are aiming for a 4 or a 5. And if you can do what we've done up until this point, up until here, then you're doing fine. For those of you who are aiming to do higher, maybe start getting used to questions like number 10. Right, I've got a few more questions to do with you. Good luck. Here we've got 5 questions from 11 through to 15. I would like you to try and do them independently. So pause the video and try out these questions. When you are ready, press play and I'll go through each one quickly. All right, let's look at question 11. So we can either make the x's match by multiplying the bottom equation by 2, or we can make the y's match by multiplying the bottom equation by 3. It really doesn't matter which way we go around doing this. Let's multiply the bottom equation by 3. So if I had to do that, the top equation stays 4x plus 3y equals 23. Sorry, not quite sure what happened with my pen there. The bottom equation, I'm multiplying by 3, so I get 6x minus 3y equals 3. Now, if we look, this is what matches. Remember, match does top, so that's what matches. Different means add, so we're going to add to both sides. If I now add the 4x and 6x, I get 10x. If I add the 23 and 3, I get 26, which means that x is 2.6 because I divide both sides by 10. Then you remember we go back to top. So I think I will use the 2x minus y equals 1 equation. So that's going to give me 2 times. Now remember, when we go back to the top, you're replacing. So I now know that x is 2.6. So I'm saying 2 times 2.6 minus y equals 1. So this gives me 5.2 minus y equals 1. You've got a couple of options here. Either you take the 5.2 to the other side and make it negative, and then divide by negative 1, or take the y across and make it positive, which is what I would do. So I'm going to say 5.2 is equal to 1 plus y. Then I'm going to bring the 1 across and subtract it. So I get 4.2 equals y, and that is my value for y. So that is the solution to question 11. All right, if we look at question 12, you can either multiply the x's so they both become 15. That would mean you multiply the entire top equation by 3 and the entire bottom equation by 5. That's a lot of work. Or, because the y's are 2y and 1y, I could just multiply the bottom by 2 and then the y's would match. So I think that would be a better solution. So I'm going to multiply the bottom equation by 2. So my top equation will remain 5x plus 2y equals 24. And the bottom equation will be 6x minus 2y equals 14. What matches are the two y's. They are different. Different means add. So I've got 11x is equal to 38. So if I want to get x on its own, I'm going to do 38 divided by 11, and I get x to be 3.45. It's 3.45 recurring, so I'm just going to leave it as 3.45. Back to the top, I'm going to put it back into that equation. So I'm going to say 3x minus y equals 7. But I now know that x is 3.45. So I'm going to say 3 times 3.45 minus y equals 7. So that gives me 10.36 minus y equals 7. Take the y across, and I've got 10.36 here. So I'm going to say 10.36 take away 7, which gives me 3.36. And so 3.36 is equal to y. So these questions are all a little bit tricky. Not my favorites, but it's important that you understand the methods. All right, we're going to do 13 next. On the screen now is the solution to question 13. So I decided that making the x's match would be too much work, so I made the y's match. So I multiplied the bottom equation by 4. So that's where I got this information from. Then these were different, which means I was adding. So 3x add 8x, 18 add 36. And when I eventually solved, I got x to be 4.9. I put that back into this equation and eventually got y to be 0.82. All right, I'm going to put up number 14 next. Here's the solution to question 14. Again, not another pretty question, but again, we're learning. So I decided this time to multiply the top equation by 3 to make the y's match. So my top equation gets multiplied by 3. So that's this solution here. The y's match. They were different, so I added. 18 add 2 is 20. 60 add 18 is 78. Solve for x. Put this back into the top equation. Solve for y. Right. We're going to look at question 15 together because that one is a little bit more tricky. So this is question 15. The reason question 15 is so much trickier than the other ones is because there's no easy fix. I cannot make the x's look the same by only multiplying one equation, and I cannot make the y's look the same by multiplying only one equation. So I either have to make the x's look the same by multiplying the whole top equation by 3 and the whole bottom equation by 4, or make the y's the same by multiplying the whole top equation by 2 and the whole bottom equation by 5. It really doesn't matter which way you go around doing this. Seeing that we've been doing y a lot, I'm going to go for x this time. So I'm going to multiply the whole top equation by 3 and the whole bottom equation by 4. And by doing that, the x's will become 12. Right, so as you can see, I've multiplied now the top equation by 3 and the bottom equation by 4. This has now meant that the x's match. They are both 12. They are the same, so I'm going to subtract the whole way through. Be very careful. We've done this one similar to this before. I'm going to be doing 15, take away -8. So it actually becomes 15 add 8. So that gives me 23y. And in the same way, over here, I've got 81, take away -16. So it's actually 81, add 16, and that's going to give me 97. So to get y on both sides, or just to get y, I'm going to say 97 divided by 23. That's going to give me 4.2. And I'm now going to put that back into the top. It doesn't matter which top one you put it into. You can quite literally pick any of the 4 equations that are on top. I think I might go for literally the very, very, very top one, simply because it's got positives in it, and I want to deal with positives instead of negatives. So I'm going to say that 4x plus 5y, but I now know that y is 4.2, is equal to 27. So I've got 4x plus 4.2 times 5 is 21. So I've got 21 equals 27. So 4x is equal to, I'm going to say 27, take away that 21, and I get 6. And so x is equal to 6 divided by 4, which is 3/2. Right. Now, we definitely did some harder questions towards the end of this lesson. To start off with, match does top was quite straightforward. And that's the thing about simultaneous equations. You can sometimes get really straightforward ones in the exams, and then sometimes you can get really ugly ones like this in the exams. But the method remains the same. All right, hope you enjoyed the lesson. Good luck.